Oh, okay. So, a little bit of the background to this. Basically, we were approached, the NCIP were approached to try and write some student learning objectives or something similar worded to do with this standard to basically support teachers. It's a snapshot in time, and it could be outdated in a few weeks or a few hours or a few days or a few months. And I guess the thing that David and I have to do is we have to do the fine path between controversy and saying nothing at all. And it's a really difficult path, but we will try and stick between the two. We don't want to tell you nothing at all, but obviously ask questions in the chat and we'll try and answer them at the end. Okay, now I'm going to talk through the student subject specific learning outcomes. All three of those are mentioned on the ministry site in different things. I think they all mean the same thing. But obviously I'll just flick to the end of the PowerPoint and come back. The actual full versions are on the website. And we wrote them and we think they work at this stage. But I'm not going to trouble you with all of them because it's way too wordy. Okay, so when we got tasked to develop these, I'll call them subject learning outcomes, we were trying to actually make sure we identified the knowledge and skills that students needed to be ready for the assessment. It builds in with the standard, it builds in with the ministry work, but it isn't just about the assessment. And quite a lot of what we put in there is actually about getting students ready for the assessment. And we'll try and explain that as we go through. And obviously we'll try and talk through each of these and just make sure they make sense to you. Okay, and we'll come back to them in detail later. Now, first thing I guess we should say, a little bit like last week, if you were here last week for the energy one, it's probably about 8 weeks. To do this properly, you probably need to do about 8 weeks worth of teaching and learning and assessing. I guess the thing I would say is that it's not physics 1.1. If you think it's physics 1.1, you've kind of missed the point of the new standard. Either rightly or wrongly, it's quite different. The specific things that are different, well, first of all, it's completely moved away from the focus on a scientific investigation. There is no need for students to write up a method or to critique the experiment or talk about errors or anything like that that was in 1.1. Those are all gone. They're not assessed as part of the standard. They probably still need to learn about them. They probably need to learn how to do an investigation still, but they don't get assessed on that directly. And they're actually only really being assessed on whether they can gather and process evidence from an investigation. Or, I suppose I better be more precise about this, the difference between phenomenon, the Muppet character, and phenomena is singular and plural. And one of the most fun things we've had this summer doing is realizing that this standard is full of plurals. And that's quite important because basically to do anything in the standard, it's not just about doing a single 1.1 relationship. It's about doing either more than 1.1, 2 relationships, or being really cunning and doing some sort of relationship or some sort of investigation where you can get 2 relationships out of it. Now, I guess I should point out at this point, because I know people will be saying, oh, that's not quite right. The exemplars from the pilot schools didn't have that flavor, nor do the assessment tasks that are currently online, but the assessment schedules that are online do have that flavor. So if you're just going off what's the pilot schools did or what is available to you, they talk about one investigation, but the assessment schedules are very clear that the word relationships is in the standard, so there have to be 2. And then the really hard bit, and I'll expand on this as we go through, the really hard bit, I think, and David can weigh in whenever he wants, the really hard bit is that the purpose of the investigations is to actually gather and process evidence that can then be used to link back to the physical phenomenon. So you've got to do an experiment, an investigation, and it's got to give you some credible evidence that you can use to explain the physical phenomenon that you're investigating. And that's actually, I think, harder than it first sounds. But anyway, I digress. Okay, so probably for me, the first thing that I think it's worth talking about for a couple of minutes is the fact that students are going to be bombarded with different words that mean different things depending upon your experience in life and whether you're a biologist or a chemist or a physicist or a non-scientist. And the 4 terms that are wrapped all the way through 1.2, physics quantities, physics relationships, physics concepts, and a physics phenomenon. And I cannot stress enough times, a physics phenomenon. Okay, the standard is not phenomena, which would be nice, it's phenomenon. Okay, now, what we tried to do, of course, NZIP, we tried to come up with some examples of each of these so we could just at least put them up and you could go, we like them, we don't like them. At the top of the slide, I'll read it out. A physical phenomenon is an observable event or process that involves physics concepts, sometimes called a physical situation. That's directly from the NCEA glossary. And it doesn't really tell you anything in particular, like how difficult the phenomenon should be or what the concept should be. So we just came up with some that we thought were appropriate. So here are our examples of physical phenomena, and there definitely are only examples. So an object falling through the air is a physical phenomenon. Motion of a wind-powered boat is a physical phenomenon. The motion of a deflating balloon is, and you'll recognize all of these from the exemplars. Heat transfer as an object cools is a physical phenomenon, and an electromagnet picking up paper clips is a phenomenon. Okay. Now, the way this standard appears to be designed is that you will have to teach the physics concepts to your students prior to their investigations. They have to be able to link these concepts into the physical phenomenon they're investigating. I was admiring SciPad earlier today, and I think SciPad's done it really nicely. I'm not associated with SciPad, but I think SciPad's got some nice physics concepts before you do the physical phenomenon. And you're going to have to probably teach this. You're going to have the examples we've got. Accelerated motion is a physical concept. Terminal velocity is. Conduction of heat is. Energy conservation or energy conversion when bouncing a ball, and buoyancy. Now, I guess the comment I'd make is that, is velocity a concept? I'm sure terminal velocity is, but is velocity on its own a concept or not? And that's probably something to be discussed by your science department or by experts much cleverer than me about whether velocity is a concept on its own. Okay, but we'll come back to that in a few minutes. Okay, at the top, again, is what the NCA glossary says a relationship in physics is. And relations in physics are connections between physical quantities that can be observed in the universe. These relationships can be represented graphically or mathematically with formulae. I wish they'd defined what the universe was. That's not on the glossary anywhere, because I'm not quite sure what that bit means. But I kind of get the rest of it. But the examples that we're putting forward are not actually equations. You could argue you could turn them into equations, but we're not suggesting that these are necessarily equations. So the mass of an object versus the acceleration when an object experiences a constant net force is a relationship. The distance an object travels versus time taken when there's balanced forces is a relationship. The golf ball drop height versus an area of crater when dropped into flower is a relationship. Okay, and of course that one, could that also be a phenomenon? That's where you get into tricky stuff at that point. Won't read the rest to you because you can read it all yourself at some point when you watch the video, if you watch the video. And then physical quantities. Again, from the glossary, physical quantities are individual properties of matter or energy or the phenomena. And my mind gets blown at that point. But here are the ones that we think are kind of appropriate to NCA level 1. Distance, velocity, force, numbers of blades on a copter, and temperature. I guess the comment to make there, which when we did this, we talked to the ministry and we talked to the NCA about what the intent of the standard was and what was going on. And they've kind of come back to us and said, the quantities have to be quantitative. They can't be qualitative. So you can't, for example, the one I like is, let's say you're doing heat loss and you're insulating a hot object and you're measuring the temperature drop. You can have a measurement of the number of layers of insulating material around the object, but you can't investigate the color of the material around the object unless you can somehow link that color to a number. And of course, there'll be some clever people out there who probably think they can, and that's great, but you can't basically go, is sandpaper better for a car to go over than planks versus concrete versus carpet? There's got to be some sort of number, some sort of quantitative value involved in that. Okay. Now, talking you through the actual assessment, and David, you can jump in whenever you want. Talking through the assessment.
Mark. You're doing a wonderful job. But I did another example that I was using for a while there, and it's not correct, and that is the classic 1.1 of roll a ball down the ramp and look at the stopping distance as a function of the height. If you then look for a second relationship that might involve the surfaces on which that roll occurs, if you could quantify the friction, I guess would probably be the obvious thing, of that surface, then that would be all right. But just saying concrete, formica, some sort of artificial grass, real grass, that doesn't lead to a quantifiable relationship. So we just need to keep that in mind. And that's really only been clarified quite recently, Mark, hasn't it? It's something that, and some of the materials that we'll talk about later, we've reflected that in what we've released out in the secure site.
Yeah, and it's probably quite, I hope it's okay to say this, when we kind of looked at this and looked at the SLOs, we kind of went to people and said, really? Is this really what students have to do? It's not like we've made this up. We've actually gone back and said, you sure they have to do all this? Or are you sure they can't do that? And that's been the responses we've got. So we have to go with that. Anyway, there are kind of 3 parts to the investigation. Okay, part 1, the students have to identify a physics phenomenon and relevant physics concepts that are suitable for investigation. They have to determine suitable variables to determine relationships, and of course they have to be numerical. And they have to carry out an investigation to collect and record the evidence. And probably, it's not a definite, and I guess we should use the word typically. Typically, this would involve more than one relationship. Okay, it is possible, I guess. The one that we've talked about at length is the terminal velocity experiment. If you can gather enough evidence from the two portions of the timing, one from before its terminal velocity and one from after its terminal velocity, it may well be that you could do that in a single relationship. But personally, having taught physics for 40 odd years, I've never been able to time that first bit accurately enough to get that initial change in velocity. I've always gone straight for the tail, but you could. It's sort of whatever works. Okay, and basically,
I think Mark, an example might be that could be done, because I think Mark's right. It's very difficult to do that. If you've got some fancy equipment, you might be able to do that first one. But if you go back to my example of the height versus the rolling distance, if you continue to move the height up further and further, the rolling distance goes down, doesn't continue to go up, because obviously at the end it's a vertical drop and it goes nowhere. So there is that was never a linear relationship in the first place, but it does have elements of extended investigation involving more than one relationship.
Yeah. So anyway, so my very awfully poor picture, this could fit into 1.1. Taking some physical quantities and working out a physics relationship could fit into 1.1, except for the fact it's like a given. It's like students do this and they don't have to worry about writing any of it down apart from gathering the results, gathering the evidence. And my biggest fear as a teacher is what happens if they don't gather useful evidence? What happens if their experiment is a mess? Yeah, that's something we're going to have to work through long term. So that's step one. They're going to do an experiment and they're going to gather some useful evidence that they're going to use later on. Okay, step two. Once they've got the measurements, they're going to process that evidence to provide more meaningful information, and they're going to present that evidence. And of course, step one is your traditional work in pairs or very small groups. Step two is you must work on your own to process the data type thing. Just like 1.1. No real difference there, I don't think. And obviously, I guess the comment to make is back to the plural and singular stuff. It is very clear in the standard and very clear when we speak to people that they have to come up with 2 or more physics relationships. That's the unfortunate thing about the S being on the end of that, and it's not in brackets. It's there as an S, and it has to be met for the standard. Okay, and there's variations on the model, but I think probably the simplest one for most people would be to just do 2 investigations on the same phenomenon and come up with 2 relationships. Not the only way, but it's probably going to be the simplest. The only thing I don't think you can do is I don't think you can do one physics relationship about dropping a copter and then with blades, another one about rolling a ball down a slope, because they're not the same phenomenon. Your 2 investigations have got to be linked to the same situation. Okay, but as I said, that's something we're going to have to work in the physics community in the next few months, no doubt. Now, step 3 of the assessment is probably the difficult bit. I know that if I was representing the NZQA here, which I'm not, but if I was, I'd be arguing that those first 2 steps almost are kind of like leading up to achieve, and you can't really get much above achieve without this last bit in detail. But the last bit, they've got to describe physics relationships or trends gathered as evidence, and that could be a formula. It could be just as this goes up, this goes down. They've got to analyze more than one relationship, and that probably, again, could be a formula. And then the difficult one, they've got to explain how the relevant physics concepts and relationships relate to a phenomenon using processed evidence. And I didn't put it in bold, but really I should have put the using processed evidence in really deep, bold colours, because they can't just say, well, we learnt about forces. I know that weight exists. I've got no evidence for my experiment for this, but I'm going to talk about weight as one of my physics concepts. The physics concepts have got to be in some way related to what they're gathering evidence about. And that's actually, I think, quite tricky. But anyway, keeping going. So, simple flowchart. This is the simple flowchart of what students have to do to gain PESS 1.2. They've got to take some physics quantities and gather some physics relationships. They've got to have learnt, or I hope been taught, some physics concepts, and they've got to combine all that together to actually explain a physics phenomenon. Now, obviously, there's varying levels of that in terms of achievement and excellence. I'm not a teacher that would just teach to achieve. I would teach everyone to excellence. And so therefore, I'm going to say, this is what you've got to do to get to excellence. But pretty much, you've got to get 2 ticks in each of those blue circles, at least on the left-hand side in the middle, to be able to get achieved for the standard. Now, because I can't not do this, obviously it looks a bit more like that. Because of the S's everywhere, you're going to need 2 physics relationships, 2 physics concepts to explain a physics phenomenon. What you do if they get 3 of those 4, I don't know. I'm not sure how that will work, or whether the 4 things are a base minimum to be awarded those credits. I mean, I guess that's one of the fun things about this whole thing, is it's really hard because a lot of this is going to come out in moderation. So a lot of the kind of real rules to this will be delayed until people have got their moderation back. And so, yeah, I
think, Mark, also it's worth stating to everybody, of course, this workshop is about the SLOs.
Yeah.
And, we're running other ones, 2 other ones about the standard. One of them is about assessing it. So we might not have, even after those ones, all the answers. We'd love to, but we probably won't. And we've got Mark and I doing that session on the materials that NZIP have prepared. But we also have a 3rd workshop on how to put together a learning program and assessing it. So hopefully by the end of all of this stuff, people will have a better idea.
Yeah, I'll flick to the next 2 slides, David, because you're kind of mentioning what's coming next anyway, in a way.
Yep.
Okay, so if I just go back, this is what the student learning outcomes have tried to explain. This is what you've got to get students to do, and you've got to understand as teachers yourself to be able to get the students to be able to access results in this particular standard. This stuff supports the standard. It's not the standard, it's just trying to support it. But obviously, as David just mentioned, if we just push forward a bit, I'm here on behalf of the NZIP, as is David, and obviously the NZIP will be trying to help by providing some of the following things, if not all of the following things. So we're working on, or actually forget working on, we've created a student template. We're going to present a generic task and schedule at a later workshop. We're going to provide examples of the specific tasks and schedules. We would hope, just as we've done with the older standards, to display some student work. We do one-on-one support. And obviously we have a regional team that can facilitate meetings and workshops that can help people come together and try and crack this nut, I suppose. The only other thing I should mention before I go to the next slide, and I think it's really important, talking to the national moderator, it's really important to stress the fact that, okay, I loved what Kerry and Matt did last week with energy. It was a really great presentation. But the good news is that only a small group of people have got to actually understand how to assess that, because it's an exam. You can do your best teaching and learning, but the exam is set by somebody else and hopefully it goes well for you. But if it goes really badly, you can go, not my fault because I didn't set the exam. This is a bit different because you've got to do the teaching and learning and you've got to do the assessment. But as the national moderator would point out, the process for doing this work is its feed forward. Any assessment you do this year, you send it away to get moderated, and whether it's good or bad, your students retain the grades that you gave them because you genuinely thought that you got the standard right. So it's not like you try something, it goes really badly, you get slammed by moderation, your kids all get bad results. You basically give the results you think the kids deserve based upon what you've tried to put together this year, and then the moderation process will give you a feed forward for next year so that you can improve the way you assess the standard. Now, of course, I suppose the naive comment here is assuming the standard isn't changed in 12 months. But basically, it is meant to be a feed forward process. So you do this, you assess it. Hopefully you kind of figure it out and you get it right. But if you are off the mark, it's not going to penalize the students in front of you. It's kind of nice in a way. It's kind of a safety cushion, I suppose. Now, as David also said, in a fortnight's time, I think David and I are back, and we'll be reviewing some of the material available for the assessment of the standard. Some of the documents we've been sent by other people, some of the stuff we've developed ourselves as an association, on how we think you assess this. And then I think it's 2 weeks again after that, James Harris is going to be presenting a scheme of work. He's done a really wonderful job in terms of writing a quite detailed scheme of work with a series of experiments and all sorts of great things. And he'll talk through that. I'm looking forward to coming to that one. I'm looking forward to listening to it. But I mean, I guess,
Mark, there's one other that we should add in there as well, and that is that two of our pilot schools, Julia and Emma,
oh yes, yeah,
who are representing two of those pilot schools, they are also presenting. So these are people who have actually done these standards, and the reflections that they've already given me have been quite valuable. So I think we probably should have popped that one in as well. So
well, never mind.
But so I think that that's yeah. So that, I mean, they're all good, I guess. But
yeah,
right, mate.
But I mean, at this point, I guess we really are straight onto this.
Yep. Well, there's quite a few questions, Dave. You can. I think we probably don't need to share the screen anymore, Mark, and we can probably.
I'll stop sharing. Yep.
Alrighty. So there's a few questions. As I was just typing into the chat, the first, I guess, nut to crack is to help the schools that plan to assess this term. One, where they can get their hands on the resources that David or Mark alluded to. Two, the unknown answers that Mark alluded to and how that might flesh out. But basically, what would you two advise for schools to do that are assessing this in the next month or so? And they can't wait for the next Zooms to actually answer those things.
Mark, do you want me to have a go at this?
Yeah, go for it, David.
That's a tough question.
It is a tough question, yes.
So, well, let's say where the resources are. So they're on our secure site. Anybody who had access last year has still got access. We're going through the registration process for this year's, but we deliberately delayed that to allow people to get in there. So go in there and grab that stuff. There's a generic task there. And in fact, inside that generic task is a specific task so there's a template there that you can put your own stuff in. But we've also got 12 or so, maybe 14, 15 possibly, experiments with a second relationship that a team of us have looked at and thought that they are entirely suitable. I think the biggest challenges, I can certainly talk from my own school science department, is actually trying to get equipment together. If having, if you're in a large school, the right enough equipment, and trying to do that, you've really got to try and do the experimentation as teachers early on. We're spending a lot of time trying to get that sorted. And I think probably the other thing I'd say is the reflection that Emma and Julia shared with me was that the time involved. Traditionally, something like 1.1 might be all done and dusted, in an afternoon. It might be 3 or 4 periods. And this thing usually takes much longer. So the experience of people having to do, a more open investigation is more time consuming. So I think that would be my advice, is you've got to factor in a lot more time for when they're working on. But also I think it's also another relevant point, because things like the investigation is not actually being assessed, your ability to intervene with students is more open, because that aspect is not. So if they are not using, if you're using ticker tapes, for example, ticker timers, and they are actually struggling to do it, you can actually get involved, because actually that's not being assessed. What's being assessed is what they do with that data and their understanding of the physics of that situation, rather than the actual investigative part.
Yeah, that makes it a totally different beastie. Yeah.
It does change things significantly.
Yeah, there's also a guideline on the ministry's multitude of documents. The assessment should be in the ballpark of 4 hours.
Well, I think, Dave, from the experience of the pilot schools, that's just very unrealistic.
That's an understatement. Yes.
But, the reality is this is 5 credits now based on, much broader, bigger standards. And there are only 60 credits towards the qualification if you factor out literacy and numeracy, which you really do have to do. That these aren't taking more time. But this is more like 10 credits worth of level 1 science, in my opinion.
Yeah, it's heavy duty. Okay, so other questions. We'll start from the beginning, and I'll just race through because I know there's lots of others that are still percolating through this. First off, where will the video be posted? I know the link for the previous one was shared on Facebook, but will those be emailed out? How will people know where to find videos from NZIP?
Yeah, so the ministry have asked, they're on our YouTube channel, but they are unlisted. The ministry have asked for that. I'm not totally sure why, but they have asked that it be unlisted, so that they will be posted on the Facebook page. We'll put it in as many places as we can, and you can always email pldsupport@nzip.org.nz, and Helen will provide you with that link.
Cool.
It'll be spread as wide as far as we possibly can, and hopefully soon it'll just become public on our YouTube site. The other one is sitting there, and it's the link will be widely spread around.
Understood. A more pragmatic question from mathematics linkage. Some people have combined a physics internal with a maths internal called bivariate. The new version of the maths internal is maths 1.1. The question basically is the PESS 1.2 able to be comboed with maths 1.1?
I don't see why it couldn't be. I mean, I'm not an expert on the maths assessment, but that would be you'd have to, I presume the maths assessment has quite a lot of rigor in terms of the analysis and the graphing and you know, the standard treatment of bivariate data, which this standard doesn't have.
Exactly.
So I think it's probably less strong a connection, and I know a lot of people used to do bivariate in 1.1. I think the linkage is probably less strong, but that's just a personal, very ill-informed position.
It's not ruled out. It's just investigate it carefully if you want to. Yeah. Okay. This has come up a few times, not just in this meeting, but previously. Does the new standard that we're talking about tonight have to be based on a real life situation? Like
when you mean, like, I think I saw the example.
Premise that you give your students, does it have to be based on a real life situation?
No, there's nothing in the standard that requires that.
Understood. That answers that. The process data element of this standard, does that allow just for averages, or does that imply creation of graphs and equations? Like, what is the definition of process data?
That's tricky, right? Because in the standard, technically speaking, putting it into a table is process data. Now, none of the people in this meeting would accept that that is a processing thing, because what would the children do otherwise? So, Mark, what would you add to that? I think it depends on context, doesn't it?
I'd add it's probably about how you use the evidence. So if you're going to want to do some sort of three-part formula with three variables, and you're going to plot two of them, and you're going to try and kind of compare the third. So let's say, for example, you're doing a velocity time thing and you want to show acceleration. That's probably best done through a graph. It's probably best done through the gradient of the graph. But if a student did it by calculation, that's also fine, I guess.
So it's still up, and basically there's still a gray area. And as you said, Mark, I think these things will fall out in the moderation epic long process. And people haven't quite twigged how long that process will be before the playing field is leveled. Okay.
I think what we can say, though, is that putting it into a table is not processing data, despite the fact that the standard might say that.
Okay. There's a few questions about, the two relationships that the kids end up investigating. First off, do the kids have to be told which relationship to investigate, or is it wide open? As well as, how close can those two relationships be? Because in some situations you can imagine a slight tweakage, and does that actually mean a new relationship?
Can I answer that, David? Or
yeah, you go for
okay, so we talked to the people who were involved in the production of this standard, and we asked them about the intent of this standard and the two relationships, and they were kind of sold very much on it being a sort of open-ended investigation, as opposed to two formulaic sets of instructions where you told the students what to do twice. Yes, it would create the same evidence that they'd need, but they didn't see that as being the intent of the standard. They saw it much more open than that. Now, intent of standard versus what actually happens is either here or there, but certainly I don't think it's one of these things where you say, here's instructions for experiment 1, here's instructions for experiment 2, carry out these experiments, gather the data, now do the next bit. I don't think that's what they expect schools to do.
Yeah. And that sort of overlaps.
It would be easiest.
Yeah, that sort of overlaps with another question that popped up repeatedly in the last, not just in this meeting, but previously, is how much overt guidance can the teacher give?
Okay, so again, I'll try and answer that, David. The first thing is that really templating is not really a big thing. We're not anticipating specific templates saying, how do you relate this to this quantity, or you've learned this concept in class, now can you measure this concept? But you are allowed, as David points out, you are allowed to be involved with the student groups, directing them in the right sort of direction in terms of their investigation. So I guess it's almost back to the good old days from like 20 odd years ago, where the students would design an experiment and then they give it to you before you actually said, go ahead and do it. In a way,
So
because
there's
you
a
don't want
feedback.
kids going off and doing an investigation that is not going to tell them anything useful,
Yeah,
I
so
guess. But
a possible feedback loop can exist. Yeah, got you.
Yeah.
Yeah, this is more science fair than it is 1.1.
Yeah.
Understood. Okay. Can simulations be used, like PhET?
Okay, so again, I'll try and answer this. Okay, we were very careful with the subject learning outcomes to talk about typically, because typically we believe it will be a practical investigation. We accept that won't work for every single student in the country. There will be circumstances where that isn't possible. Simulations may be another way around that if that isn't possible. But typically we would think that most schools will be doing this through investigations.
Okay. Here's one from Matt. Does the phenomena have to be observed in the experiment, or can the experiment be simplifications of a phenomena?
Oof.
That was Matt's question. Matt, you might want to turn your microphone on and verbalize that if I got it wrong.
Oh, I think simplification's fine.
Yeah.
I mean, you know, they're exploring a phenomenon, and they can some simplified version of it is actually perfectly reasonable. It's what we do in physics all the time. So,
I mean, as go back to the statement on the site, it's an observable event or process that involves physics concepts. It doesn't say anywhere that it has to be observable in the lab, so it could be observable somewhere else. So
Okay.
yeah.
Revisiting how much feedback loop between the student and the teacher. In an extreme case, could a teacher give methods to students to say, if you want to attack these two, you could do this. If you want to attack those two, you could do this. But it's up to the kid to do it, gather the data, process the data in some way, and then write their report.
Do you want to answer that, David, or shall I try and do it?
I don't think there's
Okay, so the reason why David and I are having this dialogue here is because we did have this discussion a little while ago. We got a couple of resources from teachers, and I suggested that the students could actually do one investigation that was scripted by the teacher, and then do a second one that they scripted themselves. And I'm not sure whether that's okay or not. I really don't know the answer to that. I know the intent is that it's because it's about a physical phenomenon that the students have got to understand the concepts and the relationships. The intent is that the students will do this themselves, but there is back to David's science fair comment, there is a danger that they could actually end up doing an investigation which ends up without any physics concepts in it.
I always thought it was always possible that they end up with a null relationship.
Yeah,
there is the magic of the mass of the ball rolling down the ramp without extreme angles. And the kids really do think it matters to the stopping distance because they don't understand the coefficient of friction and being the relationship of the normal and all that stuff. But they do think the mass matters when it's not. It's actually a null relationship. But in certain situations, there are null relationships that exist that the kids wouldn't expect. And in New Zealand, a null relationship is something that very few talk about, much less have kids explore.
I mean, we've successfully avoided, unless it's in the question somewhere, anyone discussing linear versus non-linear relationships yet.
That has not popped up. So
which I was kind of expecting because I don't know the answer to that. I don't know that you can find two relationships for a single phenomenon that's accessible to a year 11 student that are both linear.
Yeah.
I'm just not convinced about that. Yeah. I'm thinking myself at this point, trying to work one out.
No, I know. I'll out myself. With a few of us helped David and Mark tried to come up with different situations that level 1 kids could attack multiple relationships in. And it's one of the documents that David mentioned is inside the NZIP secure site. So I strongly advise anybody assessing this term to get in that folder and read everything you can get your hands on, including how multiple relationships can fit out of one beastie. And it's just, it's a bit tricky to wrap your mind around the plurals that Mark started us off on this evening.
I think, Dave, what might be worth just stating is that I think the intent of the standard is very good. I think that the challenge we all face is we're worrying about the assessment, which is completely understandable. It's the kind of thing that we do want the students to be doing, you know, exploring phenomenon and thinking about the relationships and trying to unpack them in terms of the physics concepts that they've learnt about. This is very good. The challenge we do have is around the assessment. And it's going to take some time to sort this out. When I saw a comment before from Emma, who was one of the pilot schools, and last year they did it. They were happy that processed data was putting them in a table because the children, but now things have moved on, right? So we've discussed that, and we've discussed that with the national moderator, and it's quite clear that in the normal course of events that wouldn't be processing. So things will start to converge, and it is frustrating at the moment. But what we want to be trying to be able to do is give the kids a reasonable experience and prepare them for what is their next step in their learning in physics, which is going to be level 2 physics.
Exactly.
Yeah.
Alrighty. Now, I know I haven't hit the button on each and every little question, but we are down to about 5 minutes, according to my clock, maybe 10 minutes. Are there any other urgent questions that people have that are sitting in there politely with their microphones off? Just feel free.
There are some that have just popped into the chat. Have you had a chance to look at those, Dave, or not?
It's hard to look and talk at the same time, but yeah.
Well, let's just have a look. So just give yourself a chance to read through there, because we've got 10 minutes and we should use it, because I think there are some things here. And so it's very good that people have been feeding and stuff. And in fact, there may well be things in here that NZIP can grab and try and turn them into some resources.
Yeah. One of the ways I see a common thread in some of the questions is the flavor of the two relationships. Mark explained one way where you could do 2 unique investigations. Another method that maybe, Mark, you did focus on, but I wasn't listening because I was taking notes. A kid could do an experiment with the classic IV and DV and some controls, and then pick one of those controls and start messing with that and turn the IV into a control, to talk in jargon. And it's a way that if the phenomenon has that quantitative control, that could easily swap out with the independent variable, and the kid can just keep collecting data. They don't put all the gear away. They just keep going. Once they get enough gear for their first relationship, once they get enough information data for their first relationship, they just literally keep going with one of their controls, morphing into one of their independent variables. Because that sort of is a theme in some of the questions here.
Yeah, absolutely. I mean, there are three methods mentioned in the SLOs, just as kind of our best guess. There's the 2 separate ones. There's the taking the control and changing it as you described, and there's the point where the relationship changes. And that's the third one, where you're doing a single investigation, but as you get to the extreme value, the relationship starts to change. Yeah.
Like in the rebound, drop and rebound, eventually you're at terminal velocity. So it doesn't matter if you drop it further.
Yeah.
Yeah.
Yeah, I think the other thing I'm just saying here, there's a couple of ones that are quite interesting that we haven't really talked about.
Go for it.
What Mark, you might be able to answer this. Tim's asked, what happens if you do a practice assessment which has a clear method and then the students repeat this with slightly different equipment but no instructions? They are doing a similar, that is, they're doing a similar investigation but without a given method. I think that's, you're probably in the best place to
I would say that's great teaching and learning, frankly. And so therefore I have no problem with that. I don't know. The standard talks about the fact that, the standard does talk about the fact that they can't kind of do something they've already done before. But if they are following this is why we ended up with the SLOs having things before the assessment at the standard, because we thought that bit was important, that they had to know how to do an investigation. So if they know how to do an investigation, then they can repeat that with slightly or totally different variables. That's great, I think.
Yeah.
The other one that's come up, Dave, is just, that Adam's pointed out, the good old whirling bung.
That's what I was going to mention.
I don't really want to talk about the whirling bung, but that is something that's come out this afternoon about the fact of what happens if you reach into physics that's well beyond level 1. Well, you have to provide the opportunity for the children to actually be able to unpack the physics.
Yes.
So, if they're able to do that, that's fine, but you can't put them in a position where, it's impossible for them.
So is that traditional pocket of level 2, much less level 3 stuff, much less the stuff we never talk about in high school, versus the traditional pack of what the kids learn in year 9 and 10 and 11. And you're sort of resting this on top of those 3 years before they start year 12, aren't you?
Yeah.
Yeah. So we just have
nonlinear relationships could exist, but we wouldn't expect them to linearize it. We wouldn't expect them to, do all the bells and whistles that a year 12 kid would learn about.
I mean, obviously, just reading some of the questions in the chat, I don't want to be publicizing something happening in 2 weeks, but in 2 weeks, we will try and actually say, this is the way we think you can assess this. So people who are saying, can you give examples? Yes, we will try and do that in a fortnight, and the next one of these to do with the standard.
Yeah, well, they are on the site as well. They're sitting there. We've thought carefully about those. We've spoken to NCQA about them, and it's not like they can give us an official tick, but that they had a look and said that they seem consistent. And it's also, I think that their perspective also was one of realism in terms of what can the kids do that are at year 11, at level 1, and that schools have sufficient equipment, etc., to be able to do. So, if you're in a very small school, you might be able to do. I know that James's work on his 1.2 involves motion sensors. Now, he's in a school which has access to 10 or 15 motion sensors. So, and it's a relatively small school, so every child can access that technology to collect very detailed data about motion. Now, he knows, and so do I, that that's an unusual situation. But you might be in that situation where you've only got 10 kids doing this. We had somebody come to a previous meeting, there only 40 kids in the school. So it really does depend on the context. But our stuff is trying to say, how sticky tape, rulers, masses, that stuff that you can, that you should have or that you can easily acquire to be able to roll this out with, a couple hundred kids doing this.
Yeah. But I would point Eileen and anybody else who wants examples into that NZIP Secure Site folder to find the document that David was just referencing. You'll find examples there. They do exist. Yeah. Well, we're down to about 3 minutes if we keep it to an hour. No pressure. There's a lot in here in the chat that I haven't been able to keep up with because people have gotten quite typey.
We knew this one would be a lot of chat.
It's heavy lifting because this is a new beastie. And
And we are all assessors as opposed to just teachers and learners.
Yes. Any last minute things? No? All right. Well, in that case, I'm going to stop the recording, and a few of us might want to hang out and have a little chat offline. But
just before you do that, I think Ben's just raised a question. What's the best way to share ideas? I mean, reach out to Helen on pldsupport@nzip.org.nz if you've got stuff. Put it on those Facebook things. We're looking, we're collating, we're doing everything we can. We're throwing every single resource we've got. We wouldn't have planned it like this. We're very lucky that the minister stepped in and said, make sure sciences actually has some funding, because other subjects, you know, other than science and maths, there's nothing.
That's right.
And, you know, we're in this together. I'm literally trying to help my own school get through this, and it's very difficult.
Yeah. The other thing I would say was I purposefully am not using the Google shared drive because I want them all to be in one place. And that's the New Zealand Institute of Physics secure site. So funnel them through what you just heard David Housden say, if you have resources that you feel others can benefit from. Anything else? All right. Well, I would like, right before I stop recording, just so it is actually on record, to thank Mark and David for their presentation tonight, and everybody else for giving part of their evening. And if you have questions that weren't answered, continue to reach out in any way you can. And there's the stop recording button.